Hello and welcome! In this lecture we're finally going to learn about C# generics. This is one of the most useful features of C#. It lets you create classes that you can then use with multiple types. The practical use case that we're going to do is make our grid system work with generics, so we can define a certain grid object for the logic grid that we've been using, and then we can also define a different type for our pathfinding grid whilst reusing the same general grid system logic. Okay, so generics in C#, it's actually a rather simple but extremely powerful feature. Now, even if you've never heard the name generics, you've certainly already used them. The most common one is simply a list. How you define a list is you write list, and then you write inside the angled brackets the type you want to store in that list. So for example, here we have a simple list storing integers. You can also inspect the list definition. So for example, here I've got a unit list, so it's a list of type unit. So if we right click and go to definition, yep, here we see definition. This is a generic definition. It works with a type T, which can be any type you want. So generics is just basically creating a class or function or anything and making it work with any type you want. You can use generics with a class, with an interface, function, delegate, and pretty much anything. This is a super powerful C# feature, so let's look at a practical use case. So here I have our testing script. Now here we're going to write some code just for testing. You don't have to follow this particular part of the lecture step by step. Just watch and learn how generics work. So here we can define a class. So class, call it my class. And inside, let's store an int, so private int I, and let's make a constructor to receive it. Public my class for the constructor int I, and then this dot I equals I. And let's also do a debug.log on this I. Okay, so we have this. So now, for example, in our testing, let's create a new instance of my class, and let's pass in some value, so let's say 5. If we do this, we can see there's no error. And if we run the code and press T, yep, there you go, we've got a 5. Okay, so everything's working correctly. However, now let's say that this class was a lot more complex, so perhaps like the grid system that we built, but now we want to work with a different type other than int, perhaps a string. If we were to just pass in a string here, so just pass in test. If we did this, then obviously this does not work. This class was made to work with ints and ints alone, so it refuses to accept a string. So what we want is to make this class and make it work with multiple types. So this is the obvious case for generics. How we convert a class to support generics is actually pretty simple. The syntax is we just add the angled brackets, and inside we type in a name for our generic type. Now this is just a name, kind of like a variable name, and the standard convention is to start the name with T. If you want, you can give this a long name, so for example, T custom type. Again, this is just a name. We don't have any type actually named T custom type. So you can define here like anything, and if you don't need to give it a long name, then just a simple T works. Okay, now we can use this type T anywhere we want. Like for example, over here on the variable definition. Instead of storing something of type int, we store something of type T, and in the my class, instead of receiving an int, we receive a T. Alright, so now when we create a new my class, we can create it with generics. So in this case, let's say we want to create it with a string. And then let's also make another one completely different. For this one, let's make it with an int. Okay, again, we see no errors. So here we are using the exact same class with two different types. And if we run this code, yep, there you go, both of them work perfectly. So we're using the same class, but once we are using with a string and once with an int. Now, one more thing about generics is you can add constraints. So for example, let's say we want to enforce that T extends base action. So here we can do where T extends base action. This would make this class work with any type as long as that type extends base action. So we can see up here, string and int, both of them do not interact with base action. So this is no longer valid code. But here, if we pass in, for example, a shoot action, then now this would be valid code, except here we would have to pass in a shoot action, but let's pass in null. And yep, there it is. So now this is valid code because shoot action does extend base action. Now, like I said, we've already been using generics whenever we create a list of a certain type. And also on the events, sometimes we've been using events with generics as well. If we inspect, we see that definition as well. So here the event handler receives something which it's called t-event-args, and this type is going to be the second type on the delegate. So that is why here when we use event handler combined with bool, then on the onBusyChange, if we go down here, we see that we invoke this by passing in a boolean as a second parameter. And quite a while ago, we also saw the built-in delegates, the action and func. For example, public action, and let's say an action that receives an int. So this one, again, this one is also a generic. You define the type that you want the action to work with, and same thing for the func. And this one also has a generic, which in this case applied to the result. So this is also a great point to mention another thing about generics, which is you can define them in a class like we saw here. However, you can also define it only in a single function. So let's get rid of the generics from the class. Let's put this back into an int. So just an int, and here we also receive just an int. But then let's say we have a public void testing, we have a testing function. And in this testing function, we add a generic and receive a t here. Then let's just do a debug.log also on this t. So now instead of applying the generic into the entire class, we only apply it to this one function. And how you'd use it, again, very simple. So here we make my class no longer has generics. We store the reference to my class. And then we do my class.testing, and testing takes in a parameter. So let's say testing with a string, and here just say something. All right, so that's it. This is valid code. So you can apply generics to an entire class, or just a function, just a delegate, or just anywhere you want. So now that we've learned all of this about generics, we can make a super useful function on the unit to get all kinds of actions. So let's first get rid of this code, since again, this was just for testing, so get rid of all of this. Okay, so our script is back to normal. Like I mentioned, it's on the unit, so let's go into the unit script. And up here, we've been making these various fields. So a separate one for each action. This is obviously not very good for making our game very dynamic. So let's make a function where we can then input the type that we want, and it automatically grabs that type. So let's make that function. Let's make it public. We're going to return of type t. Let's call it getAction, and we're going to receive a generic type t. And then like we saw, we can add some constraints. So let's force this t, so where t extends base action. So we're only going to receive valid t types that extend the base action, so only actions. Then over here, we just cycle through our list, which we already have a base action array. So let's cycle through that one. So do a for each base action in the base action array. So cycle through every single action attached to this unit. And then here we just test, so if this base action, if this one is of type t, if so, then let's return the base action. And if not, then let's return null. Now here all we need is to cast base action into the specific t, just like this. Alright, so that's it. So now we have this really nice function that can be used to get any action type we want. So with this, now we can finally clean up this code. So we no longer have these individual ones for getting the move action, spin, shoot, and so on. Let's get rid of all of this. Then let's go up here, get rid of the definition. So move, spin, shoot, get rid of that, all of these also. Okay, so we cleaned up all of that code and we have no errors in here. But now we need to fix all of the issues that this caused. So here in the editor, we can see all the errors. So first up on the unit action system, let's go there. Here we are, and the issue is that we're selecting the move action by default. So instead of calling get move action, let's call get action and then pass in of type move action. So this is still doing exactly the same thing. And the final error is on the move action. Over here, we get the shoot action in order to calculate the enemy AI action. So get action of type shoot action. Okay, there are no more errors, and if we play, and yep, the game still works, everything still works perfectly the same as previously. Okay, so that's generics, one of the more powerful features of C#. Now in the next lecture, let's refactor our grid system to make use of generics.